Hi folks, we're going to take a look at this question here. So they're asking us to show that this equation is true. We can't assume that it's true, so we're going to start with one side of the equation and show that it has to be equal to the other side of the equation. Okay, and I think it makes more sense to start with the left-hand side since it looks like there's more opportunity to do stuff. Okay, so I take this left-hand side and I see that I've got two different bases with my logarithm. So I should be thinking about doing a change of base. Now, while I can't use the right-hand side, I can use it as inspiration. And since the right-hand side has base 3, I'm just going to rewrite everything on the left-hand side using base 3. So here we've got 2 over. So I'm just going to use the change of base formula here. So this becomes log base 3 of the initial input, which is a, divided by log base 3 of the original base, which is 9. Okay, and I'll keep the second one as it is. And so here, what's nice about this one is that I've got a log base 3 of a, which is exactly the same expression that I have in the second expression there, and what I have on the other side of the equation that I'm trying to show it's equal to. And I also have, this is log base 3 of 9, of course, and log base 3 of 9 is something that I can actually calculate. Okay, so this becomes 2 over, so log base 3 of a, and log base 3 of 9 is just equal to 2. And so now it's just about doing some simple algebra. So here dividing by a fraction is the same as multiplying by the reciprocal. So this is 2 times 2 over log base 3 of a. So that's just going to give me 4 over log base 3 of a minus 1 over log base 3 of a. And of course, that's just going to be equal to, since we've got a common denominator, 3 over log base 3 of a, which is exactly equal to my right-hand side. Okay, so I've managed to show that the left-hand side has to be equal to the right-hand side with, of course, the appropriate conditions placed on a. Okay, they didn't ask for that, but you can figure out that a obviously has to be greater than 0, and you have to determine any a values that make the denominator equal to 0. You'd have to exclude those. Okay, so just a recap here, the main idea was to see that you had different bases, and a good trick for solving these types of questions is to just turn everything into the same base. In this case here, because the right-hand side had a log base 3, it made sense to put the left-hand side all in terms of log base 3. Okay, that's it for this one.